You're listening to Cool Air Hot Takes.
Listener, welcome to Cool Air Hot Takes, a podcast about anything and everything from the energy sector and the built environment. We are your hosts. I am Charlie, and this is Dan.
Hey there. If you've made it to episode 4, good for you. You probably know who we are by now, but if you're new, welcome, and we're glad to have you here. We've been around the HVAC biz for a long time, anywhere between designing district plants to troubleshooting stuck contractors. We're here.
And we've also been friends since 7th grade, and we both got into the HVAC and construction business. But unbelievably, it turns out that our long-suffering wives do not actually share the same love of this business. And heavy eye rolls ensued. Every time we got together, they had zero interest in what we had to talk about. So the solution was obvious. Start a podcast. So here we are.
That is still unbelievable that they roll their eyes when we talk about work. I mean, come on.
Cool Air Hot Takes.
Yeah, that's why we're here.
All right, Dano. I feel like we need to circle back on this. You went to the AHRI show. I did not go this year. And for the listener out there, the AHR show is the biggest show in HVAC every year. This year it was down in Florida. Dan, you went? Major takeaways? What did you like? What did you not like? Give us a recap.
Yeah, it was very cool. Lots of neat stuff. A lot of heating, as I think one would assume these days. A lot of air source heat pumps. A lot of modular stuff, which I thought was kind of interesting, seeing a lot of...
Like modular, like thermofit, like multi-stack, like modular?
Yep, assemble them together sort of a thing. Lots of, say, existing companies developing modular products and new companies coming out with modular products. Some, I think we talked about it on the first episode, but some CO2 compressors, and there were a couple units with CO2. AI has a presence. I went and talked to our friends at BrainBox.
It's a good lead-in for our guest today.
It's happening. Yeah, it is.
But before we get to the guest, we got to talk about a hot take. Dano, did you come with a hot take today?
I did. Tanks.
What?
Tanks.
Okay. Thanks. What's the hot take?
All right. Tanks are great. So you can do
Tanks
a lot
are great.
with buffer tanks. So think about air source heat pump applications. The placement of a buffer tank could be important. Air source heat pumps go into defrost. When they go into defrost, they make cold water. If we place our buffer tank on the supply side after the heat pump, when that heat pump goes into defrost, we have that nice big volume of warm water for when our heat pump makes cold water, so we can mitigate the discomfort effects to the space. So that's, again, loop volume, so stability in systems. So think like chillers, heat pumps that use scroll compressors that are banging on and off. Have a nice big loop volume by adding a tank. You can stabilize your system. You can do thermal storage. You could do chilled water storage and, like, say, millions of gallons of built-up tanks. You could do ice storage and, say, modular bricks or big built-up systems. You could use thermal tanks to, say, store energy when you know maybe your chiller, your heat recovery chiller can't turn down well. You can just run that bad boy, charge those tanks, shut it off, avoid, say, potential surge or turn down issues with a particular piece of equipment. So they're really versatile, and you can do a lot with tanks, and it's a very simple piece of equipment.
Did you just get done reading the ASHRAE manual on chilled water design?
I've been into a lot of tanks. I get asked about loop volume and tank sizing and defrost with air-to-water heat pumps almost every day. So I think I'm really in the tank world.
Big tank guy. Okay.
So yeah, I'm hot on tanks.
Okay. Thanks.
Yeah. What about you? You going to give us a hot take?
All right. So mine is adjacent to our space, but not exactly. My hot take is we are replacing hot water heaters too fast. And it comes down to probably the easiest maintenance procedure possible for your home appliances.
Listen up, everybody.
Well, so I'm going to ask you, the reason that this is my hot take and the reason that I am concerned about this is because a couple of months ago, we were at a fine establishment called Diesel's, and I asked you, how often do you drain your hot water heater? And your answer was?
Why would I drain my hot water heater? Do you drain your hot water heater?
Yes, religiously every year. And so since we had that conversation, have you drained your hot water heater?
I have not drained my hot water heater.
All right, so you're not...
I've thought about it. So when you brought that conversation up was the first time I was even aware that draining hot water heaters was a thing. Mm-hmm. So I've thought about it, and I've I see the drain on it. I just haven't done it. I'm contributing to the problem. I'm not part of the solution.
Yeah. Well, so real life story here. My aunt, my wife's aunt, my aunt-in-law, she replaced a hot water heater after 7 years.
Oh, that's not too long.
And they opened it up and it was just like sludge that came out of it. So all you need to do once a year, put a piece of paper, tape it on the side of the hot water heater, write down the date, close off the entry valve, open up like a faucet somewhere on the second floor, and just drain out your hot water heater. You'll see all of this sludge, all of this crud come out, and you'll get an extra 8 years out of this thing. This thing should last for 12 to 15 years, and people are replacing them every 7.
You want to know how bad I am at this then? So I did actually recently have a element replaced in my hot water heater, and we just did it on the fly. So just pulled it out, and a bunch of sludge and stuff did come out. And I was like, I should probably drain these bad boys once in a while.
There you go.
Maybe I'll do that this weekend. Probably not, but I'm
probably not. All right. Here's what we got lined up. HVAC headlines, of course. We'll get you caught up on what we thought was interesting from the week. Our interview today is fantastic. His name is Jean-Simon Venn. Thank you very much, Elena. In parentheses, she wrote pronounced the French way because he is
very
from
nice
French Canada. He's going to talk to us about AI in the HVAC space. He is the co-founder, chief technology officer at BrainBox. It was such a good interview that we're actually going to extend it out and we're going to have a longer interview and we're going to go straight to the
stat of the day.
That's right. All right, here's your headlines.
HVAC headlines. Your news today.
Headline number 1, Boston expands net zero emission requirements to new buildings and large additions. This one is from Utility Drive. We wanted to bring you this one because headlines like this and new policy like this that rolls out, especially from these large cities like Boston, New York, Seattle, LA, San Francisco, they are either part of a larger trend or they're starting a new trend. And so we want to bring this to you, especially now with where the current administration is pulling back from various climate initiatives. The federal government's not going to go after it. States or cities can. And that's what we're starting to see is some of these pockets around the country that want to go after electrification. They're starting to do things like this. And so what this headline is the Boston Zoning Commission approved an amendment that requires most, not all, but most, large buildings to have net zero carbon emissions from the day they open.
Wow, it's aggressive.
Which is tough. All right, so if you're not familiar with net zero emission means you need to offset all of the emissions that you create or create no emissions.
When does it start?
It goes into effect for new projects that are filed after July 1st, 2025.
So like now.
Yeah, it's like going into effect now. The easiest way to think of what a building needs to do is think of electrifying a building. So the only energy that the building uses is electricity. Mm-hmm. And then you add enough on-site generation through solar panels or wind to offset all of the energy that you use. So all of the energy is from renewables, zero emissions. That's where the concept of net zero comes from. You net it out to zero.
This is interesting. Are they going to be able to, can you buy carbon offsets or is this truly you have to do it?
Yeah, there's going to have to be provisions in there for how they procure that because some of those buildings downtown, you're not going to be able to put enough on-site generation for it.
Yeah, that is wild. And I mean, I think like to your point at the beginning, we're going to continue to see this. We're going to see cities and states do this like on their own, however they, feel fit for their
Absolutely.
people.
New York City's got similar rules in place. And for Boston, this is on top of BERDO, which is a building performance standard that is regulating the existing building portfolio. So this is only for new buildings that we're talking about, but they already have existing buildings too. So
and Boston really is.
You were just out there, right?
I was talking to the folks out there about this stuff and a lot more than this. This is just one example, but they're doing a lot of this kind of climate initiative stuff in many different facets. And they really are, it seems like the kind of, if not, one of the major leaders as far as cities go to implement and drive this stuff.
What were the solutions that were percolating to the top?
Well, I guess one thing that I thought I'm going to say that was just really interesting and cool is they were looking at a district energy plant. I was out for a district energy conference and they're putting in a 10,000 ton heat pump that is sourcing water out of the Charles River all year long and then making like 300 some degree hot water, which is pretty cool, I think.
Yeah, once you get above 212 or a little bit above that,
It's a steam converter.
you can turn it into steam, yeah.
I don't know how steam converters work. So if anybody email the show, tell us how they work. I would be very curious. But, to me, it's just that little box, send hot water to it and steam comes out. But it's very interesting stuff. And just, I would say a lot of these exact things, just tightening up, carbon emissions for the built environment.
Yeah.
It's going all over, from, to electric appliances, everything.
There you go.
Yeah. Up next, we have special guest Jean-Simon Venn, co-founder and CTO at Brainbox AI. He will be joining to talk to us about leveraging AI in the HVAC space.
Dano, listen. Can you hear it?
Hear what?
If your building's not speaking to you, it's time to connect with Trane's Tracer SC Plus tool. Tracer has the power to elevate performance for buildings of any age, size, or brand of equipment.
Yes. Nothing like a building reaching its full potential. Where can our listeners find out more?
Contact your local Trane account manager today or visit Trane.com. All right, listener, I am very excited about this next guest. Since we launched the podcast, this is one that I had on my list. So I am very excited to welcome Jean-Simon. Welcome to the show.
Hey, Charlie, thank you. It's a pleasure to be here.
All right. Now, before we get into the technical aspects of the work that you do, I want to share a few nuggets of information. All right, so we happen to have a common love of two things.
Oh, okay.
The first, Alpine sports.
Really? No. Really?
The second, a fine lager beer called 1664.
How can it be? I think you're the first human being that I encounter which have these two together.
I love it. So, Jean, where do you live? Where are you skiing at? Give us a little bit of that.
Yeah, absolutely. I'm based in Montreal, Canada. My home ski town is Tremblant. So Tremblant, I live there. I work there in terms of weekend job, if I could say like that. So I'm an official in a ski race, and that's my kind of second life.
All right. Well, that's awesome.
That's fun.
All right. Well, the name of the show is Cool Air Hot Takes. And when our guests come on, we ask them for their hot take. And this could be anything in the world that they live in. It could be in their personal life. So, Jean, do you have a hot take?
Absolutely. And I might create some shock here.
Okay.
So the HVAC business will become a data business within the next 5 years.
In 5
Wow,
years?
5 years.
5 years. Mark my word.
So does that mean that products, they get to the point where they're commoditized, like the controls, the AI architecture, doesn't really matter what they're controlling. They're just going to be so optimized, it's all just commoditized.
It's all about data, right? So you basically, once you extract that data and you start to create value and layer of data with that.
Yeah.
So whoever controls the data will control not only the equipment behavior, but will also create that tons of value, which is going to be what people are buying.
I love it.
That's amazing. I mean, we're talking about like 100-plus-year-old industry and massive changes within years.
Yeah. Think of cooling as a service.
Yeah.
Eating as a service.
Mm-hmm.
What are you buying? Are you buying a piece of equipment, or are you buying a controller, or you're buying just the fact that you want to maintain the temperature in the room you're in? So that's kind of what's happening very rapidly, right? Actually, when you look at the airline industry, it's already happening. When you look at the engine manufacturer, I'm not going to give any name here, but the airline, they don't even own the engine on the plane anymore. They're leasing it, but actually they're not leasing it. They're paying by mile fly on the engine.
Really?
That's
I
it.
didn't know that.
So on the CapEx, it's great for them, right? They don't have to buy these things. They don't have to maintain it. They don't have to have a mechanical crew to maintain these things, which are very complex. They just pay by mile that they're flying the plane, and everything's taken care of.
Yeah, that's interesting. On the control side of our business, we've seen more of that as a service model. On the actual output, on the cooling, on the heating side, the actual BTUs, a little bit of it, but we haven't seen a big push into that yet.
No, not yet.
Not yet, but you're thinking next 5 years, huh?
But to offer it, you need to control the data. Otherwise, you're not going to be able to offer that service. So
Right.
you really need to control the output and make sure that you're delivering it at the same level all the time. And only then you could start to offer that kind of cooling as a service. Right?
I love it. Great hot take. Very good hot take. Okay, so BrainBox, let's get here. Let's start at the beginning. How do you get to, a young lad in Canada to the spot where you're founding an AI company for building control? What was the genesis of this?
Oh boy. So, I go back to the 80s, right? So always played with technology, a lot of frustration about you want to do things, but the technology is either not ready, not existing really to do what you would like to do, or if it does exist, it costs way too much. And then I had the pleasure and actually the frightening experience to sit in the autonomous car about 9 years ago. And it's really like, it's working, right? It's like, if they're capable to do that, we should be able to do autonomous HVAC. So that was the reason why, okay, let's try to do that. Let's do an autonomous HVAC system that will basically do the continuous commissioning for a few penny on the dollar if you compare to a human doing it.
So then let's go from there. What is BrainBox AI?
We extract all the data we can from the existing controller in the building. We clean that data in terms of putting a standardized nomenclature. We tag it, a lot of tags, we enrich it, and then we take external data. Think of the weather. So we're taking that detailed weather, that airline type of pilot weather, because I want to know the thickness of the cloud at any given time at that location, so I could basically derive the solar radiation. And then we basically train a neural network. So these neural network, what are they very good at? So we're talking about the deep learning. So these neural network, what they're very good at is if you've trained them with enough data, they will give you an accurate prediction. So what is a prediction we want to know? So we basically train these neural networks so they give us a prediction of how the temperature and the humidity will fluctuate in each of the zone in that building. And they give you that prediction accuracy at 99%. So I actually know in the room you're sitting in, if we train a neural network, how the temperature and humidity will fluctuate over the next 6 hours, very precisely. So that's basically the first component of BrainBox, that knowing the future. So it's a bit like the movie Back in the Future, right? We're the capability to see the future.
It's a great movie, by the way. Great movie.
Yeah. So we go in the future, we see like, oh my God, in 3 hours, it's going to be very hot in the room you're in right now. And the system will react, right? The system will say, start the cooling, and then the temperature will go back to whatever the set point you like, or you set on the thermostat. So knowing that, we basically run different algorithms, which are typical operational research algorithm, but they were basically coded into, if you want, the ASHRAE 36 guideline. So I know how to operate a pump. I know how to operate a damper. I know how to operate a stage 1, stage 2 cooling. And basically we run all of the different scenarios. So what are all of the control strategy that we could possibly run on these equipment, and what is the outcome in terms of the future? And then we try to do what is the optimal control strategy to optimize all my objectives. So you're really into a multi-objective optimization, like think of a Pareto front optimization pattern, where you basically say, I want to reduce the costs, I want to reduce the emissions, so what is the source of energy being used? I want to reduce the cycling, because too much cycling will damage the equipment or will shorten the lifespan of that equipment. I want to optimize the comfort. So considering all these objectives, what is the optimal control strategy that I should apply right now for that equipment or for the entire equation of the equipment in that building? And we move 5 minutes in the future and we restart everything that I just described. So it's quite interesting, right? Because it's crunching a lot of prediction and then control strategy, and then it decide what it should do. So it's kind of flipping from a reactive control schema, which is what we have in all of our building on the planet, into a preemptive control schema. So of course, if you're in Texas, July, super humid, 99 degree Fahrenheit, there's only one strategy.
All out.
To run to the floor and hope for the best. So no value. But most of the time during the year, you're not in full throttle strategy. And then that kind of preemptive, that's where you see the value. That's where you bring money and you save energy, you save emission, and you reduce cycling.
And I'm assuming it's kind of twofold in terms of where you see the savings. It would be, to your point, it's those off shoulder where you're not running everything full tilt. But then also the age of equipment or age of systems, like the further you get from that day one commissioning that you were talking about, the more opportunity you likely have for savings.
Absolutely.
Throw in COVID, the amount of outside air that you need, the amount of people that are in the building, and you're ripe for savings.
It's a change of pattern, right? Change of behavior. That's where you start to basically see the automatic adaptation. You could still do it with human. You need to go get and revisit your control sequence. Okay, there's a new reality in that building, so I'm going to redo my control sequence. But the problem is like very few people are really doing that.
Mm-hmm. All right, so let's talk about actual applications. Where are we deploying BrainBox AI today? What types of systems are we seeing it on today?
Well, for a business decision, we said, let's just focus on commercial building. So we're pretty much covering all of the commercial building space. So it goes from a Dollar Tree, a small retail facility.
Should be like a rooftop unit, single zone rooftop.
Yeah, maybe 2-3 rooftop. We're doing some of the store with only one rooftop. So as soon as you have a system which has some kind of control, and it could be only a thermostat, we could basically start to do something all the way to an airport, right? So we're doing very large airports, which are very, very complex. So we cover the air side, the water side, and of course the two that are working together. And that's usually what is quite interesting. Most of the water side, when they're operating chiller plant, they are producing a quantity of chilled water, right?
Yeah.
And very often that quantity is basically circulating through the entire facility and is ready to be used. But what is the exact quantity of ton that you need per hour, really? So instead of producing a standby capacity which is ready to be used, produce exactly, once you have the prediction, you produce exactly what you need. Still keep a bit margin, but don't approach it as a static kind of, I'm producing that quantity and it's ready to be used in case. Produce exactly what you need.
When you're doing a large chilled water plant like that, do you need to know the thermostat set point or the sensor set point in every room?
That's what I was getting at, the thermostat part.
Yeah, absolutely.
Would these systems allow for fully adjustable thermostats? Like I'm imagining, humans going and adjusting things. Does that mess the stuff up, or is it?
It's one of my favorite topic, actually. I call it a thermostat war, right? So we see that all the time, right? So let's say you have an open space and somebody goes to the thermostat and they say like, well, I want 75. Half an hour later, somebody else go to the same place and say, no, I want 70. What is this thing? So the target keep changing, right? So the AI is starting to chase that rabbit, which is moving like this because the human is not agreeing on what is the desired temperature in that space. There's not much we could do. The AI will just try to follow whatever they put the target, but the AI is not deciding the target. So the human is deciding the target, and then you just try to serve that target. But generally speaking, it's pretty stable. But yeah, absolutely, the desired set point by human is a key component, and then the behavior of that zone, this is what the prediction is being trained on in terms of neural network, giving you exactly how the temperature will fluctuate. And it's very different from one building to the next, right? So each building is really a snowflake. When we say that, like it's really true. Even when you look at the retail, we're doing this chain of a mattress furniture store in Canada called Sleep Country. They're pretty much all the same in terms of configuration, but they're still all unique. And it could be the type of window, the wind, the door, which is not closing properly. It could be the sun, which is the orientation of the store. There's always some specific for each. So you really need to have a neural network learning each of the store independently.
So talk to us about results, right? What are the results that you're seeing? And maybe a case study is a good one to do here because I'm sure it's totally dependent on where you start and where you're at. But what's the result or what have you seen from deploying this either at scale or at an individual site?
So I'll give you the case of Dollar Tree. I've been mentioning that name a few times already, but let's keep at it.
We're looking for all the sponsors we can get. So yeah, keep throwing out brand names. Just keep going.
So yeah, I mean, the Dollar Tree, we're now modulating, I think, around like 2,000 store in the U.S. across pretty much all the states. Oh. And really, when you look at the number, it's quite interesting now, like, because we've been at it now for about a year, and now we start to have the measure and verification company. So you're looking like 8 gigawatt hour save, 5,000 tons of emissions save, and a $1 million in energy cost save. So this is what AI is doing, right?
On a per store average, what is that roughly?
It's varying between 15 and 25% of the energy saving.
Did any stores get worse?
No.
Okay.
No, what's happening is you might have a case where we cannot save more than 7%, and it is what it is. So, but when you look at the average, it's quite interesting.
15 to 25% just with some smart. That's a huge amount.
Yeah.
there's a lot of low-hanging fruit, right? Because you would put an engineer or a control technician on that store and say, try to get me some value. That person will find value and will save you money. The problem is that person is also costing you pretty high rate, right?
Yeah.
So then you put the two together and the equation is not that great. But the AI is running like maybe at 5 cents per hour, right? So no problem. Let's get the AI to do the work. And then you get all of the saving for you except that 5 cents, right?
So for like Dollar Tree, and I don't know if you can share this, but like what were the algorithms or what were the processes that were saving the most?
There's usually one of the key algo is what we call the Chronos. So Chronos is an algorithm which basically optimizes the start time and the close time of the schedule. So the transition from occupied to unoccupied and to inoccupied to occupied. And you'd be surprised how much we could glide at the end of the day. So the store, I don't know, is closed at 7 p.m. The regular system will shut down everything at 7 p.m. because we go in an occupied period. Chronos will start to basically glide you probably at 6 because it knows that I got my thermal mass, I'm looking at my prediction, I'm good. I could start to slow down and close it and nobody will notice because I'm going to still be on the set point by 7. So that's kind of the saving. But then we have all kind of other algorithm which will play with the damper and the cooling 1 and cooling 2 staging. Same thing on the heating side. And it's using that prediction, right? So we know in advance what you're going to need in terms of a reaction. So we try to basically canceling out in a preemptive strategy. So we have several algorithms, but each store might have a different mix of algorithm based on what's available and not available in terms of points. For us, that's a key criteria. Like, say, can we access these points? Can we read them? Can we write back to the right point we need to write back? Because that will basically limit what you could deploy in terms of algo in a given building.
So you're hitting on this a little bit with operators, but who should be the most excited about BrainBox? And should anybody be nervous for their job?
I'm going to give you the example of ARIA, and then I'm going to answer your question. So ARIA is our virtual mechanical engineer, and we made the announcements last year, and it's now in beta. And really, ARIA is this kind of assistant, which is looking at how the equipment are performing using the generative AI technology as an agent, and it basically do the root cause analysis of behavior which are troubling. So instead of basically asking the human to spend 1 or 2 hours in front of the BMS and try to understand what is going on, the cooling stage is not starting. It should be starting. Why is it not starting? Is it a malfunction? Is it like a refrigerant problem? Is it like fan? What's going on? So ARIA will be doing that root cause troubleshooting analysis and basically come down with the insights, which are, I looked into it, I looked into the trend data, I actually read the document of the manufacturer of the equipment and look at the different possibility, and it's pretty clear that in this situation we have a leak of the refrigerant. So yes, we should send a truck roll and be prepared to basically attack the refrigerant question when you get it on site, instead of just trying to find out. So suddenly, like that 1 to 2 hour of troubleshooting and finding the insight to understand what's going on is taking a few minutes. So it's a productivity gain.
Yeah, that's awesome. So technicians can just, they know what they want to go look at, they can do it quicker, and then they can get to more sites within a day.
Exactly, because when you look at a typical day, right, let's say a building manager will say it's too cold in the building, send somebody. So truck roll, we're sending a technician, the person arrive on site, start to figure out, goes on the roof, check the equipment, check the logs, and eventually discover that, now I understand what's the problem. I don't have that spare part with me. I'm going to come back tomorrow.
Yeah.
So you see where suddenly you're gaining it extremely well on productivity. And the fact that there's a shortage of labor in that specific field of field technician. So most of the ticket, they don't get really served the way they should because there's just not enough technician on the road to serve all of these tickets in a given day anywhere else in Canada or in the United States. So suddenly with the existing population of technician, with that type of tool, you could increase the productivity and have enough now man labor to do the job at a much lower cost.
That's awesome.
So it's benefit people and has become a tool, right? So I like to give the example, like, now we all have our intelligent phone and we're using email. When I started working, there was no internet, no mobile phone, and no email. We were sending letters by fax. So do I still have a job? Yeah. Do I still use a fax? No.
The tools just change.
So am I much more productive than I was back then? Absolutely. So it's just another tool that's going to make our life more productive.
All right, last part of that question. Should anybody be worried about this?
Actually, I like to say I'm going to repeat a sentence that you probably heard numerous times over the last 12 months. AI will not replace humans. Human using AI will replace you. So I think that's basically what you have to keep in mind. So if you're not embracing new technology as they're becoming available, somebody else which is using them might displace you.
What are your thoughts on some of these studies or some of the reports that show the energy impact, the environmental impact of AI in terms of the energy density, right? And so like using AI to save energy, how do you balance that net positive there?
I think if you're like Netflix, you're in trouble, right? Because when you look at the quantity of data that you're moving and you're storing, it is mind-boggling, absolutely. In our case, we're not moving movie or voice. We're moving like temperature, pressure point, percentage. So it's so tinny that really there's a very, very little impact. Mm-hmm. And even when you look at the Gen AI, right, all of the LLM, large language model, yes, the huge one, which are trying to be capable to answer all of the questions of the universe, they are heavy. They basically have an impact. But when you're using the very small ones, which are super niche and very narrow, they are running actually on a computer. You don't even need a GPU to do the inference for it. Mm-hmm. So, of course, these very small, teeny model, they're only capable to do, let's say, building engineering. Don't ask them how to do a blueberry cheesecake because they have no clue. But when they run, if you keep it at building engineering, they are running at a very small CPU and memory space. So it's all about, use these things intelligently.
All right. So if anybody doesn't want to deploy AI on their building after this conversation, I don't know who that is, but for the people that want to deploy AI on their building, what are the first steps that they need to take?
The data question, like, can we access the data which your control system is right now generating? Because if we cannot, it's end of the discussion right there. So it's the number one question.
Is that data, is that like a backnet point or is it
exactly.
hardwire points or can it be anything?
So when I started BrainBox, I was a bit worried, right? Because coming from the space, I know there's a lot of different control system out there. And how do you plug yourself to go read that data? So I did a kind of an inventory. And then at that point, I think I nearly decided not to create BrainBox because I discovered a 700 HVAC control protocol on our planet. That's going to be the barrier that's going to kill this initiative. But when you look into the detail, there's about 17, 18 of these 700, which are 80% of the pie. Mm-hmm. And BACnet is one of them, right? Mm-hmm. Tritium, Niagara is another one. Modbus is another one. So, and then you say, okay. So I'm going to forget all these 700. I'm just going to focus on these 17, 18. Make sure we could translate and basically have a gateway or talk that language. And then I'm going to focus on that. So sometimes we do hit customers which are in that 20%, and unfortunately we tell them, I'm very sorry, but there's not much we could do for you. You're in that 20%. Maybe you should call your control company and time for an upgrade.
All right, listener, like Doc Brown and Back to the Future, Jean's got all the answers. Jean, thank you so much for coming on. This has been awesome.
It was a pleasure.
Up next, stat of the day. A higher building IQ is a no-brainer, right?
You betcha.
Train autonomous control powered by BrainBox AI uses artificial intelligence to make AI work for your building 24 hours a day, 7 days a week.
So you can focus less on the little things and more on the most critical.
Bingo. Go to train.com/autonomous control to find out more about Train's latest AI offering. Here comes your stat of the day. Stat of the day. Stat of the day.
Dano, are you working on any large chilled water plants right now?
Yes, I would say at any given time I would. You know what is a large chilled plant? let's define something.
Well, I don't know if size matters here, but I would say anything over 1,000 tons, ish,
yeah. It's like a cute little plant.
Cute little plant? I mean, okay. What's the biggest plant you're working on right now?
Over 100,000 tons. Big data center. It's pretty big.
That's big.
And I think for me too, maybe from my vantage point, I deal with a lot of campuses, district energy stuff. So like, 10,000 tons, that's, getting there.
Okay, we get it.
Thing,
You get the
so I
big-
think size can matter,
Okay.
big plants,
All right. So maybe the stat of the day won't shock you, but the world's largest district cooling plant is the stat of the day. It's in Dubai and it's called the Business Bay District Chilled Water Plant. 241,000 tons of cooling. That's the capacity of this thing.
Okay, that's a big plant.
That's huge.
That
It's
is a big
crazy.
plant. That's really cool.
All right. So I put this, I wrote this out. The average American home is about 2.5 tons of cooling. That would mean that this plant can serve 100,000 U.S. homes. That's huge.
There's a lot of cool. That is so cool.
There you
I
go.
love big
Stat of the
plants. Thank you.
You're welcome. All right. Thanks for listening to this episode of Cool Air Hot Takes. Drop us a message if you want to get a hold of us, or if you have any questions, or if you have any edits that we need to know about. coolair.hottakes@train.com.
And as always, we want to hear from you guys. We want to hear your questions. We would love to hear your hot takes. We want to hear any funny or maybe not so funny stories, jobs that went sideways, anything like that, fixes, hacks. Send those over to us. And as always, if you like the show, please like and subscribe. Give us a rating and a review on whatever podcast platform you listen to. And until next time, stay cool and keep those takes hot.
Hot.